Hi everyone, welcome back to this series about the mathematics behind AI. We're really getting close now because we know what functions are and we've looked at real functions, and in this video, well, let's try to consider a formula, a well-known formula, and also how does this actually relate to functions. For example, speed, this is the distance traveled divided by the time it took to travel that distance. Well-known formula. And often, I use the letter v for velocity. Is actually x, the distance, divided by time t. And, what can I do? For example, I can fix my distance. Fix distance x. Say, I don't know, 100 kilometers, 100 miles, doesn't really matter, 100. And what I can actually consider is the velocity, which actually depends on the time parameter t. My x is fixed. And this actually allows us to look at the function v, the speed function, which goes not from all the real numbers. Time is something positive and also cannot be zero. You can also see you cannot divide by zero. So you can say, I'm just going to restrict to those real numbers which are positive and not zero. So this is my notation for all the real numbers which are strictly greater than zero. Depends a bit from country to country which notation you use for that. Just strictly positive real numbers. I end up, say, in the real numbers, and up to now for real functions I've always used in my prescription the letter x, but this is just a choice. It doesn't always have to be x. Actually, in this case, my x is reserved for the distance, which is fixed, so it's not an input of my function. It's actually the t that will vary. So I will just say every element t, strictly positive real number, this is mapped to x divided by t, where my x is fixed here. So I have a formula, and I actually, if I fix now, let's say the distance, I actually get a function. And you've seen, this is a subset of the real numbers, so I can also draw the graph of that function. For example, if my x is 100, if my t equals 1, then I divide 100 by 1. So this point is on my graph. And you can think of that this graph will look a bit like this, because the bigger t gets, you're dividing by a bigger and bigger number, so the end result will be smaller and smaller. And if t approaches towards 0, you're dividing by a smaller and smaller number, so your quotient will blow up. So that's something. Think about a function, try to fix some stuff, try to think about how can I actually see this as a function from the real numbers to the real numbers, or from a subset of the real numbers, because indeed t cannot be 0 here. Now a question you might ask yourself, the question is, if I don't want to fix x, I don't want to fix x and I don't want to fix t, can I do something similar then? So then I actually have still the formula, the same formula, the velocity equals x divided by t, but this now depends of two parameters, namely x and t. So I get actually two inputs in the function. But how does this actually work? Try as an exercise to already think about how could you write this as a function as well, with two parameters that may change. We're going to see the answer, of course, in the next video. Ciao.